Hello viewers, I extend a hearty welcome to you in this new episode lecture on my series of lectures on salt analysis. Up till now, we have discussed what is a salt, how we are to analyze the salt, what are acid radicals and basic radicals. And in this context, we chose acid radicals first. In case of acid radicals, we studied preliminary tests, that is dilute H2SO4 test, concentrated H2SO4 test and KMnO4 test for the detection of acid radicals, and then the conformation of acid radicals which were detected with dilute H2SO4 and concentrated H2SO4 tests. Now in this today's lecture, we shall be starting the discussion of preliminary tests which are basically helpful in the analysis of the basic radicals in a salt. So this is basically preliminary tests helpful in the detection of basic radicals. These tests basically help in the detection of basic radicals. However, some indication regarding the presence of acid radicals is also obtained. Now, in this group of tests, we come across number one, physical examination. Number two, dry heating test. Number three, cobalt nitrate. And plain charcoal cavity test. Then flame test and borax bead test. Out of these tests, basically the helpful tests are physical examination, then dry heating test, and to some extent flame test also. Charcoal cavity test, cobalt nitrate charcoal cavity test and borax bead test, these are a little difficult to be performed, and generally students don't perform these tests, and we also don't stress upon these tests. So basically physical examination, dry heating test and flame test will be discussing here. In case of flame test also, basically flame test is performed with the help of a platinum wire. All of you know that platinum is very costly and platinum wire is also not available in pure form. However, we have some alternatives, and those alternatives I'll be discussing when we discuss the flame test. So I repeat that primarily we'll be doing physical examination and dry heating test and then flame test. So first of all, we start with the physical examination. You know, in case of this test, we take the salt on a watch glass and then following observations are done. Number one is color of the salt, oblique mixture. Second is smell or odor of the salt. And third is density and or physical state. So in this case, first of all, we start with color of the salt. In books, you get a table which discusses various colors of the salts and then what are the inferences. So I'll be writing just here, I'll be writing here color of the salt, and then here will be inference, that is cation present. First of all, if the salt is bluish or bluish green, bluish or bluish green, it indicates the presence of copper 2 positive, that is a cupric ion. If the salt is green, say parrot green like that, so then it could be due to nickel. You see, there are number of shades of green. If we have got light green or bottle green, it could be due to ferrous. And again, if it is dark green, then it could be due to chromium. Now, if we get pinkish, bluish, it could be due to cobalt. And if we have got light pink, then it could be due to manganese. Sometimes we get brownish colored salt, brown. If it is brown, then it could be due to ferric. And sometimes we get yellow colored salt. If yellow colored salt is there, then it is due to the presence of ferrous oxalate or ferrous carbonate. And if the salt is white, that is no specific color, then these radicals, that is copper, nickel, ferrous, chromium, ferric, cobalt, manganese, etc. may be absent. You see, we use the word here may be absent because these are preliminary or indicative tests. These are not confirmatory tests. Sometimes there must be some salt which has a very, very light color and it may get masked in the mixture. So we say that may be absent. Now, this was first observation, that is color. Now, we come over to the second observation, that is smell or odor. Smell or odor. We take the salt and just rub it between the fingers, of course, gloved fingers, with a drop of water, and then we smell it. If a particular characteristic smell comes, then it may indicate the presence of some ion. For example, if we get ammoniacal smell, it may be due to ammonium ion and particularly ammonium carbonate. Number two, if we get smell like that of rotten eggs, you see, it is due to basically when we put a drop of water and rub it, then hydrolysis takes place and the vapors of the characteristic gas comes out. So smell like that of rotten eggs comes, you know that this smell is due to the sulfide, so sulfide radical could be there. Number three, again, if we get the smell like that of vinegar, you remember we had this experience in radical with concentrated sulfuric acid, that is acetate. So if we get smell like that of vinegar, then it may be due to acetate. Sometimes we get a little smell like that of burning sulfur, not much, but a little feeling of smell like that of burning sulfur. It could be due to sulfite. And no characteristic smell. No characteristic smell. It could be absence of these: ammonium ion, sulfide, and acetate, etc. may be absent. So this was second part. And the third part is density and physical state. Density and physical state. What do you mean by density? You see, we take a small amount of the salt on say watch glass and just weight, or you can have it on a paper and just have a feeling of the weight. There are certain salts which are heavy, and slightly heavy salt than the normal salt will give the indication. Heavy, then it could be due to salts of mercury. You see, some salts of mercury, then lead, barium, strontium, etc. They are heavy. So if we get the slight heavy feeling, then the salt could be any salt among these salts. Then is physical state. Then in physical state, it is salt is fluffy. You know, fluffy is very light, like talcum powder. So if it is fluffy, then it could be due to carbonates of non-alkali metals, basically those of barium, strontium, and calcium, etc. So by performing these tests, we can examine the salt physically, and we can conclude that any radical from these observations, any radical could be present in the given mixture. So let's conclude the first part here, and in the second part we'll be discussing the dry heating test and subsequently flame test also. Thank you very much.